Hello and welcome to Algebra 1, Chapter 6.4. Today we are solving compound inequalities. And so there are two types of compound inequalities that we're going to talk about. Okay, so today we're going to get into compound inequalities. And so first of all, if we define a compound inequality, it's two inequalities considered at the same time. Two inequalities considered at the same time. And there are two types of compound inequalities we're going to talk about. The first one is an AND inequality. And inequalities are true if both inequalities are true. Because remember, we're considering two at a time. So if we say 4 is less than 6 and 4 is greater than 2, both of those are true, and so the AND inequality there is true. When you graph an AND inequality, you're going to get an intersection. Okay, so if we say something like x is less than 6 and x is greater than -1, we are looking for the numbers that are between those. So these would be open circles. So if I put an open circle on 6, less than 6 would come to the left. But on -1, I'd also put an open circle, and greater than -1 would go to the right, and what we end up with is an intersection, or they overlap. And that's what an AND inequality looks like, is that your answers end up being anything from this overlapping section. All of those numbers in there are less than 6 and they're greater than -1. Okay, so at the beginning here, we're just going to graph these solution sets. So first of all, we need a number line. Remember, you need to go one past each number you're plotting, so we need to go from at least 4 to 13. Okay. And to graph y is greater than or equal to 5, we put a closed circle on 5, and greater than would go to the right, and I'm not going to finish that yet, because I'm going to come over to 12. Y is less than 12. That's an open circle on 12, arrow to the left, and you end up with this intersection, and that is the graph of an AND. So there you go. So let's try the graph of an AND one more time. First of all, we need a number line. This one needs to go from at least -6 to 1. Okay, and to graph A is greater than -5. That's an open circle on -5. Arrow to the right, because that's the greater than -5. And to graph A is less than 0. That's an open circle on 0, arrow to the left for less than 0. And again, you get that overlapping section, and that is what an AND looks like. So the next thing to do is to solve them. And one thing that I didn't mention on the previous slides is if we have x is less than 6 and x is, let's say, greater than 3, that the way you write these is you put x in the middle. You always put your small number on your left, the big number on the right, so x is less than 6, and reading it from the x is greater than 3. So notice that both those inequalities are in there. So here the less than side was by the x, and it still is right there. And here the greater than side was by the x, and it still is over there. So this is how you should always write your answer to an AND inequality. And so typically I would say that equations have two sides. These, I say, have three sides. So if you look here, this is an AND inequality. In fact, ANDs are the only ones you can write this way. You are trying to get z by itself. So how is it that we could get z by itself? we would subtract 2. And so what happens is, instead of just saying subtract 2 from both sides, you have to subtract 2 from all 3 sides. So you get 5 is less than z less than or equal to 9. And there is your answer for your and inequality. And then we are also asked to graph it. So we're going to go 4 to 10. And we have an open circle on 5, and if you read it from z, z is greater than 5, so that would go to the right. And for closed circle on the 9, and again if you read it from the z, z is less than 9, and you end up with that and inequality. So do make note though that that is how you write and answers. Okay, so notice we have an and again here. Y minus 3 is greater than or equal to negative 11, and y minus 3 is less than or equal to negative 8. If they come to you as 2 separate ones, I would go ahead and keep them separate, and we want to solve them both. So how do you get y by itself? We're going to add 3, make sure those cancel. Y is greater than or equal to negative 8. And then on the other one, also add 3, so that turns out nicely. Y is less than or equal to negative 5. All right, so if this is an and inequality, you should be able to put y in the middle, your small number, which in this case is negative 8, your big number, which is negative 5, and these should work. So there's my less than. This one on the other side, notice the y, it reads correctly from the y. So small number to big number, and your inequalities should open to the right. So notice both of those open to the right. So we solved each one, we put it together as an and now we're going to graph it. We're going to put in closed circle on negative 8, and that would go to the right because y is greater than negative 8. And we're going to put a closed circle on negative 5, and that would go to the left because that's less than negative 5, and there's your answer. There's your graph. So the other type of inequality is an or inequality. And for an or inequality to be true, at least one of the statements has to be true. So if we said 4 is less than 6 or 3 is greater than 2, that's true because one of them is true. Okay, where an and, they both have to be true. So when you graph an or, your graph is the union of the two, not the intersection. And so what a union means is just, it's just everything. Where for an and, we were just looking for the overlap. A union is whatever's on the graph, that's what we're looking for. By the way, here are your symbols for intersection and union, because remember the and graph graphs an intersection, and the or graph graphs a union. Just so you're familiar with what these would mean, if we had this set of numbers, 1, 2, 3, and 4, so let's say A was that set of numbers, and we had another set of numbers, let's say is 3, 6, 9. If you want the intersection of those numbers, you'd write it like that, A intersection B. So the intersection is where do they overlap? They only overlap at 3. That's the only number they have in common. But if you want the union of those numbers, that is all the numbers that are there. So you get 1, 2, 3, 4, 6, and 9. That is every number that's there, no repeaters. So that's what intersection and union mean. A ski resort has several types of hotel rooms and cabins. The hotel rooms cost at most $89 per night, and the cabins cost at least $109 a night. Write and graph a compound inequality that describes the amount a guest would pay per night at the resort. So first of all, you probably should define your variable. And so what is x going to equal? X is going to equal, or x is going to be the price per room. Okay. So hotel rooms cost at most, so if x is the cost of a hotel room, at most $89. So less than or equal to $89. Cabins cost at least $109. So then x has to be greater than or equal to 109. Okay? So you can't be less than 89 and greater than 109, so this is an OR. And when you graph an OR, we'll just count by tens here. When you graph an OR, let's see here, less than or equal to 89 is a closed circle on 89, arrow to the left, that is less than 89. Greater than 109 is a closed circle on 109, arrow to the right. That is what an OR looks like when it's graphed. They're going to go opposite ways. So let's look at another word problem. Alright, so here we have a store is offering a $30 mail-in rebate on all color printers, and Louisiana is looking at different color printers that range in price from $175 to $260. How much can she expect to spend after the mail-in rebate? So let's do some quick math to the side here. If she has a $30 mail-in rebate, how much would a $175 printer cost? Well, it would cost $145, okay. What about a $260 printer? $230. So if the price range is between those two values, that's where you get an and inequality. And we get this between, and it's between $145 and $230. Okay, so if you read this from your x is greater, going this way, x is greater than 145 and less than 230. So there's your answer. It's that range between those values. All right, two more examples here we want to look at. So the first one here is an OR statement, and when you solve an OR, you have to solve them separately. So we have two separate inequalities here. And we're going to solve them separately. So the first one, we're going to add 7. Remember, you undo your addition and subtraction first. And then we're going to divide by 4. And k is less than or equal to 8. And the second one, we're going to subtract 12. Make sure whatever operation you're doing, they do cancel. Divide by negative 9. K is greater than, oh, we divided by negative, didn't we? K is less than or equal to negative 2. Okay. So this is an OR, and so the OR stays in the middle. But if you look at this, this says that k is less than both of those. Well, that doesn't make much sense. And so if you graph this, let me see if I can count correctly here. So the graph of k is less than or equal to 8, closed circle, arrow going this way. The graph of k is less than or equal to negative 2, closed circle, arrow going this way. Typically, ands go both ways. They go opposite ways. This time, they're both going the same way. So if you look at this, this blue arrow is going to keep coming this way and take over everything that the red arrow touches. So instead of saying both of these answers, we actually only have one answer, and that one answer is k is less than or equal to 8 because it encompasses all of the other k is less than or equal to negative 2, so we don't need to write both. In this case, you only have that one answer. So we're going to look at one more here. Solve x less than or equal to 9 or 2 plus 4x is less than 10. Notice this first one is already solved for us. X is already by itself. So if we solve the other one, we're first going to subtract 2, make sure it cancels. Then we're going to divide by 4, and we're going to get x is less than 2. And once again, notice that they both go the same way. So if I bring down the other one here, keep that or in the middle. You have to keep that or in the middle the whole time. So if we graph these, we are going to get an open circle on 2, arrow to the left, and we're going to get a closed circle on 9, arrow to the left. And again, if they go the same way, do you need both of them? So the answer there is no, that this blue arrow on the right is going to take over everything on the blue arrow on the left. That then is our one and only answer. So that only happens in an or if they go the same way. So another special case we will talk about in class next time. Make sure you have these notes done and let me know if you have any questions. We'll see you in class.